Hello everyone. Today we are going to discuss the fifth problem of AtCoderBeginner Contest 340, which is Mancala 2. So what is the problem? So we are given n boxes numbered from 0 to n minus 1, where the box I contains AI balls. Now Takahashi will perform the following operations for I from 1 to m. So these points will make the problem more tricky. So let's look at the examples only. There is an interesting animation at the example, so you will understand it better. So what are the inputs? In the inputs we are given n means the number of boxes and m means the number of operations. Hmm. Here the values of AI, the AI means that there are AI balls in the ith box. Now what are the values of BI? BI means that we will choose the ith box and distribute the balls in the ith box in some way. Okay, so let's look at that. The animation will give us more overview to you. So initially the first box will contain one ball. Similarly the ith box will contain I balls. At the first operation we will choose the second box, and what will we do? We'll take all the balls from the second box. There are initially third box. Actually this is zero based indexing is used, so 2 means that this is the third box. So we will take all three balls from the third box, and we will put one ball in the fourth box, then one ball in the fifth box, and one ball in the first box. Okay, after that we will choose the fourth box. Four means the large box. Five so there are six balls now, because we have added one ball in the previous operation. So we put one ball in the first box, one ball in the second box, one ball in the third box, one in the fourth, one in the fifth, and again one in the sixth. Okay, so here you can see that initially we are taking three balls and adding in the third, fourth, and fifth. Now we are taking five balls and putting in zero, like this. Okay, so you can look at this animation. I hope you understand what the problem statement says. So how can we solve this problem? So what you can do, the brute force approach. The brute force approach is nothing but at each operation we will have bi balls, and we will reiterate over for I in range I, for I from 0 to bi. We'll take x. Let's say x is nothing but our I plus let's say our initially we are given bi. Okay, so let's call it j. So we'll do j plus bi modulo n, ji plus bi plus 1 modulo n, and add one ball to the x box. So we'll do a of x plus plus. Okay, so this is the brute force algorithm. And initially we have to mark a of bi box as 0, because we are taking all the balls. So this is the brute force algorithm, and this will solve the problem for us. Now what is the time complexity for this algorithm? The time complexity for this algorithm is nothing but order of summation of order of something like we are n into m into ai. This is something of order of m into ai. Now look at the constants. So what are the constants? The constants on ai is 10 to the power 9. So this is not possible. So we can't do that. We can't add one ball for each query. We can't add one ball at one box and do for all the balls. That is not possible. Okay, so these steps are to explain that this is the algorithm, the pseudocode, you can say. Okay, so how we can solve this problem? So how, for solving this problem, uh, let's say we have five elements. Okay, or five boxes, you can say. Five boxes and 10 balls, and we will use the same algorithm. We'll start from the first box. Do first, we'll add one ball to the first box, one ball to the second box, third box, fourth box, fifth box. Let's say we are adding 12 balls. Okay, now six ball, this is the sixth ball, the seventh ball, 8, 9, 10, now 11 and 12. So you can see that if we divide 12 by 5, so we are adding two balls to each of the boxes. So we are adding two balls to each of the boxes. And what is the remainder? Remainder is nothing but 12 modulo 5. So there are two remaining balls. We will you add two remaining balls at the first two boxes. Okay, so let's say instead of starting from the first position, let's say we are starting from the third position. Okay, so let's say we are starting from the third position. So we'll add one ball, two ball, three ball, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So you are seeing that the extra two balls that we are adding is starting from the box from which we have started our current operation. So let's say we have now let's say p equals to a of bi. That means that the number of balls in the bi box. So we'll start from bi plus 1 box, and let's say we are taking two things. Let's say d is nothing but p by n, so we'll add p by n balls to each of the n boxes. And let's say r is our p modulo n, so r is our p modulo n, so we'll add the balls from bi, one ball from bi plus 1 to bi plus r, right? So bi plus 1 to bi plus r. So we are adding d balls to each of the boxes from 1 to n, and we are adding 1 balls to from bi plus 1 to bi plus r. Now let's say we had 14 balls, we had 12 balls, right? Now let's say instead of 12, let's say we have 14 balls. So we are putting the 13 balls in this last box, and we have to put 14 balls in the 14th ball in the first box. So bi plus r could be greater than n also. Then we have to take 1 2 bi plus r minus n. Okay, we have to add so we have to add so what we are doing, what are the update operations? Let me write it here. Initially what we are doing a of bi is equals to 0, a of bi equals to 0. Now what we are doing, update all the boxes, let's call it from 1 to n, we are updating d. Okay, now we are updating 1 let's say this is the starting position, this is the ending position, and this is the value. So we are adding d balls. Now we will update from d plus 1, sorry, not d, we will add bi plus 1 to bi plus r, and we'll add 1 balls. Now bi plus r could be greater than n, and then we will take minimum of bi plus r comma n. And we will do one thing also, the last update operation will be nothing but 1 to bi plus r minus n, and we'll add 1 balls. Okay, so the problem is quite straightforward. We have to do 4 update operations per query. And after all the operations are done, we have to print the number of balls in the ith box. Now we are doing some range updates and a point query, or you can do range query also. So for that we will use segment tree with lazy updates. So I will provide the link of the GFG code in the description box, which I have used. I will not going to explain what segment tree with lazy propagation does, because that will make the video longer. You can find it in GFG or any YouTube video. So I will just explain to you that what are the update operations and what are the query operations. Let's look into my code now. Okay, so here this part is for segment tree lazy updates. So what we are doing, for every ai value we are updating the ith position. So this is the for update range, this is the number of nodes, this is the start and the end value, and this is the changing value. Okay, so we are changing the ith point for the first operation, the initialization part, you can say. Now we are getting sum for the bith value. So what are the number of balls in the bith node, and we are doing g equals to p by n, and the remainder is p modulo n. So we are doing update range n comma bi minus p. So this is the first update operation. We are doing e of bi equals to 0. We can't set anything at a particular node in the segment tree, so we are doing e of bi is equals to e of bi minus e of bi, you can say. That's why we are doing minus p here. Okay, and this is the, if d is greater than 0, we are updating all the values from 0 to n minus 1. When we are updating the value from bi plus 1 to bi plus r, we are taking minimum of n minus 1 also, and we are doing the second update operation here. So we are doing 0 comma bi plus r minus n. Okay, I hope you get it. And at the end we are printing the sum for the ith node. I hope you will understand the solution. The solution is quite straightforward. Just you have to copy the segment tree template from somewhere. I will provide the GFG link of the segment tree with lazy propagation also, and also the my code link. You can find it in the description box. If you find this video helpful, please like the video and subscribe to my channel. Thank you.